Hello, fellow chemists. In this video, we're going to take a look at Lewis dot structures. This is labeled an intermediate video because it assumes you have a basic understanding of ionic and covalent bonds. If you need a review of those topics, I will put a link in the upper right-hand corner. So Lewis dot structures, what these are really useful for is when you start to try to draw Lewis structures for covalent bonding. And if you understand how to draw a Lewis dot structure, it makes it a lot easier to figure out from a formula how to draw out an overall Lewis structure for an organic compound. So let's get started with some example Lewis dot structures. So I put down four rules on how to do a Lewis dot structure. First, you write the symbol for the element, and let's go through an example as we do this. So let's take a look at the element nitrogen. Again, these Lewis dot structures are going to be most useful for the nonmetals, because remember, when you have a covalent bond, it's two nonmetals making the bond. But you could do dot structures for the metals as well, and we'll do a couple for the metals. So if you take a look and we draw the symbol for nitrogen, and then it says place a dot around the four sides of the symbol for each valence electron. So you want to kind of pretend that the symbol has like a four-sided box around it. So I'll just put this little red line here for the four-sided box, and then we'll erase it at the end. And it's very important to note, well, how many valence electrons each of these elements have. And hopefully we know by now that elements in group 1 have one valence electron, elements in group 2 have two. Elements from group 3 through 12, the transition metals, they usually have two, but sometimes it's one, so I'll put a little star next to it. And then elements in group 13 have three, 14 have four. I'm sure you see where this is going. Group 15 have five, 16 have six, 17 have seven, and group 18 have eight valence electrons. Because the dot structure is only going to show the valence electrons. Because remember, the valence electrons are the ones that are involved in bonding. So we place a dot around the four sides of the symbol for each valence electron. Well, it says nitrogen has five valence electrons. So we'll put a dot up here, that's one. Then you put a dot on another side, that's two. It doesn't matter which side you put the dots on first. Then put a dot down here, that's the third one. Then you put a dot over here, that's the fourth one. You got one left. And it says do not double up dots until there is one dot on each of the four sides. Okay, we got one dot on each of the four sides. We still have one valence electron left. You can double it up on any side that you want, but I'll just double it up here on the top. And that would be the dot structure for nitrogen. It says, depending on the element, the dot structure will have between 1 and 8 dots, or 1 and 8 valence electrons. So nitrogen has 1, 2, 3, 4, 5 valence electrons. Now, it's important to know that these electrons that are paired up, these are called non-bonding electrons. And then if those are the non-bonding ones, then the electrons that are not paired up, like this one, and this one over here, these are the bonding electrons. And you can tell just by drawing the dot structure how many covalent bonds a nonmetal is going to make. Nitrogen is going to make 3 covalent bonds because it has 3 bonding electrons. Now, it's very important to include these non-bonding electrons because when you draw the overall Lewis structure, you have to put the non-bonding electrons in as well. So let's do another example, probably one of the most important elements when we're looking at covalent bonding. We'll take a look at, say, carbon. Carbon is in group 4, so it has 4 valence electrons. Again, we'll put our little imaginary box around here. Since it has 4 valence electrons, we'll put 1, 2, 3, 4, and then there's nothing to double up, so that's it. So what this means is carbon has 4 bonding electrons, and it's going to make 4 bonds. Now, there are cases where carbon will not make 4 covalent bonds if you have a carbocation or carboanion, but if you're just learning how to do Lewis structures, your professor is most likely just going to give you relatively simple compounds to draw the structure out for, and you're not going to have charges on any of the atoms. So carbon, based on its dot structure, will want to make 4 bonds. If we say take a look at any of the elements that's in group 14, they're all going to want to make 4 bonds. All the elements in group 15 will make 3. All the elements in group 16 will make 2. Let's take a look at an example there for oxygen. If we take a look at oxygen, it's in group 16. That means it has 6 valence electrons. And a lot of people will think, well, 6 valence electrons, it wants to make 6 bonds. No, it wants to get to 8 electrons. It doesn't. The number of valence electrons doesn't mean the number of bonds that it's going to want to make. So again, it has 6 valence electrons, so we put 1 dot on each side. Then once they're all doubled up, then you start to, or all 1 on each side, then you can start to double them up. So there's our 2, 4, 5, 6 valence electrons. Remember, the electrons that are doubled up, these ones and these ones, these are non-bonding electrons. And it's just these two that are going to make a bond. So each one of those will make a bond. So we'll make 2 bonds. So oxygen will make 2 covalent bonds. So all the elements in group 14 will make 4 covalent bonds. All the elements in group 15 would make 3 covalent bonds. I'll just write that on there. So 4 covalent bonds, Cb. And then these guys will make 3 covalent bonds, Cb. These will make 2 covalent bonds. And then these guys in group 17 will make 1 covalent bond. And hydrogen also makes 1 covalent bond. Okay, so you can kind of tell from which group the nonmetal is in when you draw its dot structure how many covalent bonds it's going to make. Let's take a look at one of the elements in group 17 here. It says it should make 1 covalent bond. Let's look at its dot structure to make sure that that would be correct. So we'll take a look at bromine. And again, we don't care about the total number of electrons. We only care about the valence electrons. And all the elements in group 17 have 7 valence electrons. Put 1 on each side. That's 4. And then you start doubling them up. 5, 6, 7. So we have 3 pairs of non-bonding electrons. And then only 1 bonding electron. So bromine will make 1 bond. If you can easily and correctly draw out these dot structures, it will make it much simpler for you when you're working with covalent compounds and covalent bonds to figure out what the overall Lewis structure of the molecule is. All right. That's it for this lesson. I hope you learned something. If you did, like and subscribe, and I'll see you in the next video.